So we're going to start recording. Okay, good afternoon, ladies and gentlemen. Welcome to the continuation of Lecture 5. We're going to finish off Lecture 5 today, where I'm discussing shared and helper methods or utility methods, and then tomorrow we're going to start composition. We are starting to run a bit behind schedule in a certain way, but we will make sure that everyone is caught up to the work and we don't go too fast. Okay, I'll answer any questions about practicals after the lecture. I'm not going to focus on them now. I'm going to focus on the work. Just announcements. Remember, if you haven't done designs, make sure you do designs for practicals. If you haven't found a team, I think we'll give you guys up until next week, Wednesday, to find teams. Else we'll start auto allocating then, because then we should have a finalized list of students. And again, when you do the auto allocation for teams, we'll allocate you to people that have done the same number of practicals. Again, if you have any issues with practical marking, there's a Google form. You can fill out any issues and we will then look at that Google form. No, Prac4 isn't a group project. Group project's going to come later in the semester. The group project's going to be either practical 9 or 10, much later. It's got nothing to do with current work. Okay. We'll announce when the group project is. Until we announce it, assume every practical is solo. Okay. And again, ladies and gentlemen, one thing I want to point out to everyone that is here and everyone listening to the recording, do listen to your assistants when they give you feedback in terms of improving your code. No one, including myself and Mr. van der Westhuizen, know everything about programming. Even though we have years of experience on you guys, we are still learning to program and we can learn how to program better. So don't assume that you have 1 year or half a year of programming, that you know everything. You still have a lot to learn. So please do listen to your assistant's feedback. Take what they say to heart to improve your coding. It's important to actually improve your coding and not get stuck in an incorrect style of coding. The assistants are trying to encourage better style and better practice. So please, again, listen to your assistants. Don't just ignore what they say or think you already know the work. Else you're shooting yourself in the foot. Make sure you actually take what we say to heart, not to heart, but the principles we are applying, take them. Those are the more important things. I've got a hand raised. You got your question?
Good day, sir.
Afternoon.
Sir, can you please upload a video on whereby you explain how can we convert a Word document into a PDF? Because our markers are saying that we should upload using PDF and not Word.
Okay, convert Word to PDF. Okay, I'll do something on that.
Okay, thank you, sir.
Okay. Okay, well, that's fine. I'll make a YouTube video on it. It's quick and easy. Okay, let's start today's lecture and we'll go from there. Okay, so again, we're finishing off lecture 5, as we never actually finished it off. We kind of started with the basics and then moved from there. Well, not the basics, we kind of did the working with classes in the form of demo, and then we started the utility methods where I showed you the Professor Hulk, and then what actually is happening behind the scenes. So with programming, there is ways of hiding what is happening. Okay, so this is what we want to see, what it should be seen. This is what actually is happening. So when programming, even here, you see the difference between the two. Okay, if I answered your question, okay, Ray, lowered your hand. You can see the difference between the actually what's happening and the final result. This is actually a nice picture for that. It shows the difference between what's actually happening on site and what we're seeing. We don't see all the nitty-gritty parts. We don't see the antenna going on his back. We don't see the facial rig. We don't see the sensor points. We see just that on screen. With programming, sometimes we want to do that as well. We want the person to see only the parts that are necessary, the important parts, the functions that they need to see, and we want to hide some of our code and hide it and use it without them being aware of it. So This is where utility or helper methods come in. Some people don't like them. Some people say they aren't the best approach, but they do help with improving your code. So, like you have I've got the example of a utility knife here, a Swiss Army, or a fake Swiss Army knife, I guess, since it doesn't have the logo. It is a knife, but it has a lot of utility to it. Helper methods are typically not complex. They are shortened to help with frequent tasks. I'll explain what that means in a minute. I got another hand raised. Zita?
Yes, I want to ask something related to the utility method or helper methods. Since
Go for it.
they will be private, will they be triggered by our public functions?
Yep, that's
All right,
exactly how
thank
they work. That's
you.
exactly how they work.
All right. So
Okay?
would it be okay to have some in this week's project?
Yeah.
Because I tried to add in some.
No, you're welcome to do it in this week's practical.
All right, thanks.
Okay. As Mr. Zita pointed out, I hope I'm pronouncing your surname correctly, pointed out, they're there, but they're not triggered. They are private methods, but they're triggered by your by the other public methods. So they're there for like validation. They're there to do calculations. They're there to do certain things behind the scenes, never being used, never being seen, but are being used in the code to complete certain functionality. Okay, so here's an example. It's not the best example, but here you have your example class. You have your public function that does something, and then you have your private function secret method that does something. What it does, it could be validation. I'll try to do an example if we have the time during the lecture. It could be validating. It could be comparing values. It could be doing calculations. But the thing is, from the person's outset, they don't see it. They don't see this method. They only see the do something. They can't access this method either. They can't invoke it. The only thing they can invoke it is the class. So it's there to assist and provide extra assistance to the class, to the object. The object can, well, not the object, the class. Because in the class, you'll structure it how it will interact. The one comment, like our function to access the grid, correct? That is a utility method. It's a private function designed to help us put something in the grid. It is a utility method. Okay, but it's in your form code. But it serves the same purpose as a utility method. So it could be used for validation. I'll give you another example later on. I'm trying to think besides validation. You also can use it for calculation. Since we've got a few more people on, I just want to do a, Mr. Van der Westhuizen, can you trigger a poll for the YouTube Blackboard comparison? I just want to see what this group thinks, and then we'll do a Google form later as well. So while that's being done, any questions on utility methods? Is everyone okay that a utility method is a private method designed to support the functionality of the class? Does that make sense? Okay. Okay, it's not there to, it's the, you can do calculations in it, you can do anything you like in it, but it's there to support the functionality to, like when we go back to abstraction. Okay, Mr. Van der Westhuizen's got the poll. We're checking on who would prefer lectures being done on Blackboard or YouTube. We're just trying to figure out which one's a better approach for you guys since there is connection issues, etc. And Blackboard's winning by a landslide. Okay. Okay, we'll keep that going for a bit. So it's designed to do calculations, it's designed to support. Going back to what I said about abstraction, remember, object-oriented programming, we abstract the code. Okay, we try and only show what is needed to the user. So we don't want to show them all the methods. We only want to show them the methods that are applicable to them, that we want them to use. So in that sense, utility methods are used. We want to encapsulate as well. So we want to house the correct methods. So, but the main principle that's being applied here is the abstraction. of the methods. We only expose methods to the user or to the other parts of the program that are needed. We don't expose everything because not everything is needed. They don't need to know how every calculation is done. They don't need accessibility to do every calculation and run every function. They only need to be able to run functions we deem necessary as the developer. So that's where our private functions come in. Methods that only are accessible by the class and the class only in the terms of the object. I need to be very careful how I phrase it as we're going forward. Okay, any questions on utility methods? I will try to do a implementation later on if we have the time. I need to discuss another topic as well. Any questions on utility/helper methods? I'll give you a minute. Implementation will be better. Okay, I know implementation will be better. Worst case, we'll do it in the tutorial tomorrow afternoon. Right now, we need to cover the theory, so I will get to the implementation. Basically, yes, it's just private functions in the class. But you can't just have a private function and not use it. It must be used in some aspect. It must be used within a property method or must be used within a subroutine or another function. Having a private function that does nothing is useless as well. So it must be used somewhere. Can you change variables in the class from utility? Yes, you can change variables. Variables can be used to do calculations. You can use them to do calculations. Yes, as I just said. You can use them to do calculations. So you can expose one function that says here's the result, but that function uses another 3 methods to do the calculation. So yes, it can be used. The next thing I need to discuss is what is known as a shared. Okay, and this takes time to understand. And this is where your understanding of objects and classes becomes very important. Because something that is shared doesn't belong to an object. I'll explain what I mean there. So shared is specifies that one or more declared programming elements are associated with a class or structure at large, are not specific to an instance to a class or structure. Keeping that lovely sentence there, basically a shared method or instance variable does not belong to an object, it belongs to a class. Okay. Other languages refer to them as static, but static is a keyword inside VB as well, so just be careful of that. I discovered that while doing design, setting up the lecture slides. Static is a keyword within VB for something else altogether. Shared is creating a variable or a method that doesn't belong to an object specifically. Okay. And you're probably like wondering what the hell is he smoking when I say that statement. So a shared variable doesn't link to a, I'm going to go to the next slide, we'll come back. Yeah, I kind of figure. Okay, so we have our class whatever. We can create objects of that class. Everyone okay with this objects? Okay. We then have shared variables. Shared variables are accessed via the class, not the objects. The objects know about the shared variables, but they don't have direct access. So going to the code here. Now, here I have a public class component part. It has a private shared ID. That means this variable, and this is important, the memory, the allocation of this doesn't belong to an object. Okay? It belongs to the class. You'll see that in a moment now when I use it. A very good example of something that's shared. Most of you, we were talking about maths before the lecture started. In maths, is the value of pi constant? is the value of E constant. Okay. Pi is constant, it's just a very long number. Okay. But pi we use without really worrying about what pi is. We just know that math.pi gives us a value. Okay, that is a shared variable. We don't need to go and create the object of type maths, but we can use the pi. I'll show you that in code in a few minutes. Shared variables belong to a collective group almost. So all objects share one piece of information. Now, I think me drawing this might help. Just don't mess with the blackboard, whiteboard. Okay, when you create a, I'll show you how it's accessible from the form. When you create a class, when you create an object, say this is an object. Let's go with what we had last week, client. And the client has a name as Bob. The client has a ID. And the ID is 7 or 6, whatever. Okay, this is the information that belongs to a client. Now, for our class, we can have something like this. Hopefully, I'm explaining it correctly. If I'm confusing you guys, please say so. Shared isn't always the easiest thing to understand first round. So here's our class, client. It has a next ID, integer, and it's shared. Okay, so it's a shared variable. Then, of course, you have your name, string, and you have, I can't press enter this thing, and you have your ID. As integer. No, we don't have two classes. We have an, I'll rather not explain it now. Okay. This is an object. This is a class. Okay, so let's just do object class. Better. Do you, okay, I've shown you we have name and ID as part of the object. Is the next ID part of the object? Do you see it being listed here as part of the object? No, okay. It doesn't belong to the object. It belongs to the class. So what you can do, and what's quite nice with it, is you can do a constructor that does this. Public sub new. And then it goes and says that the next ID plus equals 1, and ID equals next ID. End sub. The purpose of next ID is to keep track of the next unique number. So when the program starts, next ID starts at Pokemon card, yeah. So next ID also is important to understand it belongs to the class. How will you know where to end? There's no reason to end. Every time I make a new object, next ID just increases by 1. There's no real end. So what happens is there is client. Every time we create a new client, let me just draw the damn thing. Okay, I'll draw another class, maybe it'll draw rectangle. Because when we create the next object, we're going to create client again. This is the object we're making. This object's name is going to be Jane. What is the ID of this one going to be? Seven. If this one is 6, this one will be 7. Because every time we call the constructor, the next ID goes up by 1. Okay? Because next ID, unlike these two this is the instance, this is a block of memory you can think of in the computer. These pieces of memory store the information for clients as objects. Shared ID, the next ID, which is shared, doesn't belong to these two. It belongs to client. Okay? See, my spelling's horrendous there. So essentially what happens is there's a separate piece of memory with the how to draw this properly, piece of memory with the next ID housed in it. And that keeps track of its current situation. So it's currently sitting at 7. And when the constructor runs again, it goes to 8 and affects the next object. I will explain this again. Don't worry. I know this is confusing some of you. So wait, well, I need to stop that. No, there it is. Now, if we look at the bottom here, every time you invoke the constructor, it goes up by 1. Every time you invoke the constructor, it goes up by 1. So what can a shared variable be used for? It's to be used outside the class. Now, if we look at the code, I'll show you what I mean by that. Here, I'm going text display, and I'm trying to display the ID which is shared in this code. So I've shared ID. You notice it doesn't like me saying component, which is the object, dot ID. It doesn't like that. To access a shared variable, it's the name of the class, dot ID. So it is in a, what happens is all the objects, also important, shared variables, all the objects share the same piece of memory. So if we change the shared variable for anyone, it affects all the objects. So a shared variable is something that all the objects can see, have access to, and are affected by. But it isn't directed to one specific object. It's directed to the class. So if you're an object of type class in this case, you have there is the shared variable that you all have access to, a common memory allocation. And I'll probably confuse more people with that. So what is shared variables used for? Shared variables are useful for allowing a person to create a variable that exists outside of an object, a method that exists outside of an object. You can create a set of functions that exist outside of objects, that exist in classes. I'm trying to think of a better way to explain this. Mm. Yeah, if we do the same thing, like the question asks, if we don't have ID as shared, then every instance variable has its own ID and they don't link. Okay, what happens is I can't increase the value of ID consistently between all the objects, because the way I've designed it now is every time I try and create a component part, I create a new ID for that component essentially. So end of the day, no matter how many objects I make, I can keep track of how many objects I've made through the create ID functionality. It allows us to access information without creating objects as well. So we don't necessarily need to create an object to access the shared information. I'm more used to the static in C# and that. No, the shared ID is declared in the class because it belongs to the class. It doesn't belong to the object. Shared doesn't belong to an object, it belongs to a class. And that's the one key definition, is that it belongs to a class. So shared classes structures makes it available for every instance, rather than a shared member of a class or structure makes it available to every instance, rather than non-shared, where every instance keeps its own copy. So basically I have one variable, one piece of information that is accessible to all the objects. Okay, all the different instances. If it's not shared, they all have their own one and they don't like anyone seeing it. Shared is useful for the example given. If a variable if the value of a variable applies to the entire application, if you declare a variable as shared, then all instances have access to the same storage location. And if one instance changes the variable, all instances can see the updated value. So if I decide, okay, let's see, one example. The slides we're using right now are being shared, correct? Everyone has access to the same set of slides. You don't all have your own copy of slides. If I make a change to the slides, everyone gets affected by the change, correct? That's shared. Okay, so same situation with your practicals. They are shared. If we see a mistake in a practical and we've got to update it, we update it. You guys will then just have to download it or access the new updated version. You don't have to go and redo it from scratch again, or you don't have access to the new version. A shared variable is consistently accessible by all objects at the same time, and if it changes at any point, all the objects can be made known about the change. Does that make sense? Okay. You can say kinda and you can say no, I don't mind. Okay. Let's give you some examples. A lecture of, where's this one going? No. Okay, I'll show you where shared is currently being used already inside VB and inside programming languages. So some things you guys are forgetting. Always put your statements on. Okay. None of you guys have ever used the math class or object. Now inside maths, there's a whole bunch of methods. Okay, sound, round, power, pi. These are all shared methods and shared attributes. We don't need to go and create object type math to use these. They are usable outside the object. So we can access them without going and creating an object. We can just use these functionalities. That's one benefit of shared. So let's go to the example of a production system or a manufacturing system. Class parts.bb. Say every time you manufacture a part, it must get a unique ID. Okay? So every time a new part is made, a unique ID must be done. Private, and this is I'm going to use my next ID example. Private shared next ID as integer. And my constructor and the actual part will have its own private ID. So every time I call the constructor, next ID will increase by 1 to get the next value, and ID will equal that value. So it allows us to consistently make sure we have a new ID or part for each component being designed or developed or manufactured, however you want to think about it. But it gives us the ability to consistently have a new number. If it wasn't shared, there would be no way to constantly increase it. Why don't we make ID a shared method? The next ID or the ID? Which one are you referring to? ID, okay. Thing is, each part, think about your cell phone. Every cell phone, every laptop has a serial number. Are they the same? Okay. Now, how do we know? Would it make sense to have every computer having the same serial number? No. Okay, we'll have issues. So what I'm doing is, if ID was shared, that means then everyone would have the same ID number. With having the shared next ID, I'm creating a variable that exists outside of the object. So this next ID belongs to the class. So every time the class is asked to make a new object, it uses the shared variable that has a value, it has its own memory assigned, and it uses that to generate the new number. And then when the next object is created, it uses the next ID to create the new number. So it keeps referring to this next ID as a holding place to get values from. So we have a consistent point to work from. And every time we invoke a constructor, we change next ID. So the next part will have a new ID. And we'll use ID in the form, correct. But ID will always be a read-only. So we go public read-only property ID get return, better get the type, return ID. Okay, we don't go and return next ID. Next ID doesn't really belong. There's actually situations where you can make next ID public. Okay, and in the form, I can actually go and say part dot next ID. You can see it's there. It belongs, it doesn't belong to the object, it belongs to the class. Anything that is shared belongs to the class. But I wouldn't make it public because this is a dangerous feature as someone could screw with the next ID. So I would never make it public here, not in this situation. I'm just showing you that it can become public. I would make it public through either a function or property method like I showed you. I actually discovered when I was designing the slides, you can have a read-only shared property method, next ID, as integer. And again, this controls, remember, the reason for property methods is control. We want to control that the person can't screw with the code. We want to control that the person can't mess with our information. In this case, we want to make damn sure they don't mess with the unique number generator. So I can't access it now, but I can access next ID, I think. ID, yeah. It's read-only since we're not writing the ID, correct? We don't want the person giving the ID. Remember, when a part is being manufactured at a company, someone's not sitting there going, okay, this ID is this. It's automatically being generated. That's where an idea of next ID would come in. It will automatically generate the next ID in the sequence of IDs. There's more advanced ways of doing a more complicated ID, I know. We're just showing you simple steps in terms of a shared. A shared is very useful, especially if you want to have access to something without creating an object. An example of that would be using, why are you complaining? Property access must be assigned to the property or use the value. Oh, it wants me to display, so MSG box string. It doesn't like this being used there. An example of this is math. Math class has a lot of, good, I like your example. The example is, it's like a person's order number at the restaurant. Yes. Think back when we were on campus and you ordered something from any of the restaurants in their student center. They would give you an ID for the day. That ID would then allow you to get your food on your order. That's an excellent example. Thank you. That's the same situation. Every time a new order is made, a new ID is generated. But it's got to keep track of the IDs that have been used as well. That's where shared kind of comes in. Shared allows us to keep track of what we generated. Since this doesn't belong to an object, it belongs to the class, it allows us to have a bit more free range. Now, what I was going to the example of, we have math.power. Actually, pi is there. We have math.e, I believe, is here. These are attributes. We have a math.power. Now we can invoke math.power, and that says x 3 to the power of 7. And that'll calculate 3 to the power of 7 for us. It's a function. Am I creating the object maths? Am I creating an object of type math? No. I'm actually just saying maths. I'm using a function that is shared outside as a shared variable, without creating the object. It allows us to have access to sections of a class or methods of a class without creating the object, which is also very useful to use functionality, create functionality that is reusable in other places. Okay, we don't use shared very often, but it's something to keep in mind of. I promised if there's time, I'd show you a private utility method. Let's quickly do one. I should have enough time, so let's do a public property age as integer, private integer get return age. Okay, I want to make sure that they can't mess with the number, but the problem is I don't want to keep making validations for every single integer. So I'm going to have a function valid int value as integer. It's going to return an integer. If value is less than 0, then return 0, or not dash, else return value. So when I set age, I can go age, not age equals valid int value. And where did I break this? Oh, my spelling's bad. Okay, so I can validate age. Now I want to validate something else. What is an integer? What else could I use? Okay, with this utility method now, any integer I want to validate based on this criteria, I can just call validate int and use it. I've got like 2 minutes left of the lecture, so I can't spend too much more time on this anyway. That's an example of a utility method because it's private, it's hidden inside the class. Only the class can use it, only the class can see it. It can then be used to support the other public methods, be it property methods or methods themselves, functions or subroutines. It helps to validate, it can help to calculate, it can help in any simple process, and we can keep using it in other property methods. Okay, so we can continue to use it in other property methods as well. Wherever it's an integer and we want to make sure it's a positive value, we can just use the valid int function without having to rewrite the code every time. So it's a way of reusing code effectively without having to literally copy paste, which most of you guys do in any case. How you display utility method in UML, that's actually very easy. If we go to lecture 4, you see that everything is public. If something is utility, it's negative. Valid int value. I'll move it up now, don't worry. By simply saying it's a private method, it's a utility method. The second it's private, it's a utility method. Okay, that's it for today's lecture. We've hit the time, so I'm going to stop the recording. I'll still be online for questions. Okay, wait, that's an important question. I won't stop yet. If I had a constructor, would we call age instead of property method? In the constructor, I would call, okay, that's actually a good question. Thank you for bringing it up, as someone else will bring it up later. In my constructor, what I do, say I got age coming in here, age value as integer. We still have to teach you something else before I can start messing around with the parameters. What age equals age value, or what I call age equals age value. Which one out of these two? Option 1 or option 2? You're not looking at the question properly. Age links directly to the instance variable, yes. But if I go through the property method, does it validate it? Yes. If I go through the property method, it validates it. by using validate A, int. So by calling this one, I'm validating the value as well. And I'm not just going through it directly. So this is not the best approach. This one at least validates the age coming in to ensure we're getting the correct value. But if this one is used, we are using the instance variable directly and we're not validating. So it's up to you to decide, do I go through the property method with validation or not? And that's a choice you got to make. If you don't want to validate it and potentially break your program because of that, that's your choice. But again, you can call the constructor in the property method, yes. Remember, programming, there is not ever one solution. It's an art form. You take your thinking, your work, your creative thinking, and you combine it into one. So technically, as Moses has said, we can do this. Valid int, and do that as well, yes. This one looks neater. But it actually depends on the individual, I guess. Okay. That is the question that's very important. I'm going to end the recording. Again, I'll still be online on Blackboard for a bit. Any problems, any questions, you can ask them then. Else you Discord, or you can comment on the YouTube video as well. I do check the comments.